Example 1, determine the domain and range of each of the following. In the first graph here, we have a line with arrows at the ends. So let's start by looking at the domain. What you need to do is just kind of scan to the right and scan to the left and see if the graph ends anywhere. So if I scan to the right, I know that the graph will continue growing in that direction. And if I scan to the left, it will continue to grow to the left as well. So there's no restrictions on what the x coordinate could be. So that means when I write the domain, all I have to write is that x belongs to the real number set, meaning that it can be any value. Okay. Now let's look at the range. When I look at the range, I'm going to scan up and then down to see if the graph ends or stops anywhere. So scanning up, I know it's going to continue to grow upwards. Scanning down, it's going to continue growing downwards because of the arrows. So for the range, I'm going to have a similar situation, but range is associated with the y coordinates. So I'm going to write y belongs to the real number set. And that would be the domain and range. So x can be any number or any value, and y can be any value. Okay, let's take a look at B. Here we have another line, but this time we don't have arrows on both ends. So starting with the domain, I'm going to scan to the right, and I know that it's going to continue going to the right. Now I'm going to scan to the left. When I scan to the left, I notice that my line stops here, right here. And it corresponds to an x-coordinate of -4 because I scale my x-axis by 2's. So this happens to be the lowest x coordinate that I have on this line. The rest of the x-coordinates of all the points on the line have to be greater than -4 because they're to the right of this point. So for example, this point has an x-coordinate of 4, and the number 4 is greater than -4. So how do I write the domain? You start by writing that x belongs to the real number set such that my x-coordinates have to be all greater than or equal to -4. So there's one x-coordinate where it's equal to -4, but the rest of the x-coordinates, like 4, if I was to replace x with 4, will be greater than -4. Okay? Now let's determine the range. We're going to scan up and down. Scanning up, I see that the line ends here at a y coordinate of 4. So 4 is going to be the highest y coordinate that we can have, okay? Because the rest of the y coordinates are going to be lower since the points are all below this highest point. Okay? And scanning down, it's going to continue to grow down. So the only thing that's restricting our range is this point here with a y coordinate of 4, and 4 is the highest value that we can have. So we're going to write y belongs to the real number set such that y has to be less than or equal to 4, because 4 is the highest of the rest of the y coordinates. For example, if I take this point here, this has a y coordinate of 0, 0 will be less than 4. Okay? Let's look at another line. This one has 2 endpoints. Okay, so if I scan to the right, I have this point where the line ends, and it'll be at an x-coordinate of 2. And then if I scan to the left, okay, this point is going to have an x-coordinate of -2, and it stops there. So the lowest x-coordinate is -2, and the highest is 2 on this line, and then you have all the points in between. So to write the domain, there's 2 different ways you can do it. We start by writing x belongs to the real number set such that x is going to be greater than or equal to -2, and at the same time less than or equal to +2. So that's one way of writing it, okay? Just like this. Or an alternative is to separate those together. You can write x belongs to the real number set such that x is going to be greater than or equal to -2, and, so you have to put the word and in between, x is going to be less than or equal to 2, like that. So two ways you can write the domain. Okay? Most people prefer to write it this way, as long as you put the lowest x-coordinate on the left and the highest x-coordinate on the right, the signs will go in the same direction here, pointing to the left. Okay, now for the range, if we scan upwards, the highest y value here is 3, and if we scan down, the lowest y value that we have on this line is -1. So writing the range, we're going to write y belongs to the real number set such that y has to be greater than or equal to the lowest value of -1, but less than or equal to the highest y value of 3. Again, alternatively, you can break it up into two parts and write y belongs to the real number set such that y is going to be greater than or equal to -1 and y is going to be less than or equal to 3. Okay, let's look at the next graphs here that we have. Another line, but it's a vertical line, so a special case. So notice that if I look at the domain, all the points on this line have an x-coordinate of 3. So for domain, you can just write 3, and you're done. Okay, for the range, if I scan up and down, okay, up and down, the graph's going to continue growing all the way up and down, so there's no restriction on what the y-coordinate can be. So we're simply going to write y belongs to the real number set. Let's look at a parabola next. If I scan the parabola to the right or to the left, the arrows indicate that the parabola gets wider and wider, so there are no restrictions on what the domain's going to be. So I write x belongs to the real number set. However, for the range, if I'm scanning up, the graph doesn't go past this maximum point. Okay, the y-coordinate of this point is 3, so the highest y value on the parabola is 3. The rest of them are all lower or less than 3. And the graph continues to go down. So the range, we have y belongs to real number sets such that y is going to be less than or equal to 3. Okay, next we have a circle. Okay, if I scan to the right, the graph stops here at an x-coordinate of 3. If I scan to the left, the graph stops here at an x-coordinate of -3, and then you have all the x-coordinates in between. So the domain will be x belongs to the real number set such that, remember we put the lowest x-coordinate first, and then you put the highest x-coordinate last here with x in between. For the range, it's going to be the same thing. Scanning upwards, the highest y-coordinate is 3. Scanning down, the lowest is -3. So our y-coordinates are going to be in between -3 and 3, and including those values. And that's how I would write it. Example 2, it's a word problem. It says, a baseball is thrown from the top of a 30-meter building. It reaches a maximum height of 31.25 meters before falling to the ground below. It hits the ground 3 seconds after being thrown. State the domain and range of the relation. So it's helpful to draw a graph from which you can determine the domain and range in such situations. So I'm going to have two variables. I'm going to have height on my vertical axis, and I'm going to use the letter H to represent height, and the units for height are meters. And then I'm going to have time on my horizontal axis. I'm going to use T to represent time, and units will be seconds. And I'm just going to draw a sketch. Okay. So this will be around 30 meters. If I see everything here by 5, and then 31.25 would be somewhere just a little bit above it. Okay, and then the time I'll just scale by halves. Okay? So what happens is the ball or baseball is being thrown from top of a 30-meter building, so time t equals 0, the height is 30. Then at some point it's going to reach this maximum height of 31.25, and then it's going to come back down to the ground and hit the ground 3 seconds later. And that's what the graph looks like. Now, looking at the graph, I can now state the domain and range. Okay. Scanning to the right, I know that the time is not going to be any higher than 3 seconds. Scanning to the left, I know the time won't be anything less than 0 seconds. So the time is in between 0 and 3 seconds, and 0 and 3 is included. So I'm going to write my domain. Now, since my variable is not x here, it's t, I have to use t here. So time belongs to a real number set such that 0 is the lowest time and 3 is the highest time. That's how I write it. So time has to be greater than or equal to 0, but less than or equal to 3. Range. And if I scan it up, the highest points over here, it stops over here at a y value of 31.25. So that's the highest height I can have. And then if I scan down, the lowest height that the ball will be at is 0 when it hits the ground, 0 meters. So again, using h instead of y, I have h belongs to real number sets such that 0, h, and 31.25. So that says the height has to be greater than or equal to 0, but less than or equal to 31.25.